All right, let's dive in. Today we're going to decode something you think you know, the periodic table. But trust me, this isn't the boring, dusty chart from your high school science class. We're about to see it as something, well, incredible.
So let me ask you this. What if you had a map? A map of the entire universe, not just stars and galaxies, but a map of the building blocks for, well, everything. Every planet, every person, the phone in your hand, everything. Sounds like science fiction, right? Well, it's not. That map exists, and that's exactly what the periodic table is.
Okay, so what exactly is this map? Well, think of it like the legend for our universal map. It's a chart of all the known chemical elements, the absolute fundamental ingredients of reality. And it's not just a random list. It organizes every single element by its atomic number and chemical properties. It's the key that unlocks how everything works. So how many of these fundamental ingredients do you think there are? Thousands? Millions? Nope. Get this. There are only 118 known elements. That's it. Every single thing from the air you're breathing right now to the screen you're watching this on is just a combination of these 118 things. It's kind of mind-blowing, isn't it?
All right, tour time. Let's explore this elemental city. First up, we're heading to the biggest neighborhood by far, the metals.
And our first stop here is, you could say, the wild side of town. Meet the alkali metals. These guys are the most reactive, high-energy residents in the whole elemental city. I mean, they're so soft you could cut them with a butter knife, but drop them in water? Whoa, they react violently. They are absolutely the wild ones.
And believe it or not, these wild elements are everywhere in our daily lives. The battery in your phone? That's powered by lithium. You know that salt on your fries? That's sodium. The same stuff that makes streetlights glow that classic orange. And potassium? It's a key ingredient in fertilizers that help grow our food. See, they're all around us.
Okay, let's head one street over to meet the neighbors, the alkaline earth metals. If the alkali metals are the wild party animals, these guys are, well, a little more chilled out. They're still reactive, for sure, but they're harder, a bit tougher, and definitely less volatile.
But don't mistake chilled out for boring. Their impact is huge. Magnesium? That's what creates those brilliant, bright white lights in fireworks. And calcium? Wow, it's the foundation of our world. It's not just in our bones and teeth. It's a key ingredient in the cement we use to build our cities. These elements literally hold our world together. Now, as we move toward the center of our map, the whole vibe of the city just changes. We're leaving the soft, super reactive elements behind and heading into the territory of the transition metals. And these are a completely different breed. We're talking hard, strong, and fantastic at conducting heat and electricity. This is really the industrial heartland of our elemental city. Think about it. Iron gives us our buildings and machines. Copper is the reason we have electricity in our homes, running through all those wires. And gold? Well, its beauty and the fact that it doesn't rust has made it special for thousands of years. This group right here, they built the modern world. Right next to them, we've got the post-transition metals. Now these guys are a little softer, not quite as tough as their neighbors, but they are still so useful. We're talking about lightweight aluminum for things like airplanes and foil, tin that keeps our canned food fresh, and lead, which is crucial for car batteries.
Okay, let's head over to a really special place on the map. It's this unique little border region right between the metals and the non-metals. And this small neighborhood, it's the undisputed tech hub of the entire elemental city. So what makes this tiny group, the Metalloids, so important? Well, they have this one superpower. They're semiconductors. That means we can tell them when to conduct electricity and when to stop. And that one little trick, it's the magic behind all modern electronics. Silicon is the heart of every computer chip. Germanium and arsenic are key for transistors. Let me put it this way. Without this little neighborhood, there is no digital age, period.
All right, let's jump all the way across the map now, over to the upper right corner. It's a totally different world over here, home to the non-metals. And if the metals built our cities and machines, this neighborhood builds life itself.
I mean, just look at how fundamental these are. Carbon is the backbone of all life as we know it. Oxygen is, what we breathe to stay alive. And phosphorus is a critical piece of our DNA. The truth is, we are literally made of this stuff.
Now, inside this non-metal world, there's a group that's super reactive, kind of like the alkali metals we met earlier. They're called the halogens, and we've actually learned how to use their intense reactivity for good things. Fluorine in our toothpaste protects our teeth, and chlorine purifies our drinking water, keeping it safe. And finally,
Way over on the far right edge of the map, we find the loners of the periodic table, the noble gases. You can think of them as being perfectly happy on their own. They're so stable that they almost never react with anything else. But we found some cool uses for them, right? Helium fills up party balloons, and of course, neon gives us those awesome glowing signs.
So you've probably always wondered about those two rows that are kind of floating at the bottom of the table, right? What's up with those? Well, they actually slot right into the main table, but we pulled them out just to keep the whole chart from getting way too wide. Let's take a quick look. This first hidden row is the lanthanides, or as you might have heard them called, the rare earth elements. But here's a fun fact. They're not actually all that rare. What they are is incredibly important for modern technology. Those super strong, tiny magnets in your phone or earbuds? That's them. The powerful motors in electric cars? Yep, you need these guys. The second row down there, that's the actinides, and this is the radioactive row. Most of these don't exist in nature. They're man-made, they're unstable, and they are immensely powerful. This is where you find heavy hitters like uranium, which we use for nuclear power, and plutonium, which has been used for nuclear weapons. And that brings our tour to the very edge of the known map, the final frontier. We're talking about elements that don't exist anywhere in nature. These are the ones we had to make ourselves. Yeah, the elements way down at the end of the table are completely synthetic. They're born in labs, inside giant particle accelerators where scientists smash atoms together hoping to create something brand new. But here's the crazy part. They're so unstable that they often exist for just tiny fractions of a second before they disappear. We are literally adding new locations to our map, even if those locations vanish in the blink of an eye. So that leaves us with one last really cool question. Right now, our map officially ends at element 118. But scientists are already trying to create 119, 120, and beyond. So, what lies past the edge of the map? What other fundamental ingredients of the universe are still out there, waiting to be discovered? And how will they change everything we think we know? The exploration, for sure, is far from over.